Hi, my name is Mike, and today we are going to do the shark dissection lab. This is the first part to the lab. This is the external anatomy of the dogfish shark. So I'm going to go ahead and share my screen. Alrighty, so in this first picture, we can already see many aspects of the shark, uh, many of which are the fins. Of course, we could see towards the middle of the shark here is the dorsal fin. This is a very famous fin, of course, in the movie Jaws and other shark movies whenever it breaks the water surface. But it aids in maneuverability and nimbleness for the shark. That same function carries throughout all of its other fins. Here we can see the pectoral fin and another one on the other side of it, of course, beside its gills. And then we have a series of pelvic fins, the tail, and in this case, the dogfish shark has a posterior dorsal fin. Now, what makes the shark a great predator is the amount of evolutions it's undergone over time that make it very dangerous. So one of these features, of course, is its cartilaginous bone structure, as well as its streamlined body shape. So due to its body shape, and why it is like that is because it lacks a swim bladder, which is typically found in bony fish. And that acts as a pumping mechanism to siphon water and exchange oxygen. And it allows buoyancy of the bony fish and its ability to remain stationary in water. Sharks can't do that. So in order to compensate for that lack of a swim bladder, they need buoyancy through their oily cartilaginous bone structure. Because oil is lighter than water, it helps aid in buoyancy, and also the amount of fins that it has to maintain its position in water, especially in this case of the tail. The tail's function being it's the largest fin and it's lobed, the top portion is larger than the lower half lobe, and as it moves, it forces the shark's head up, maintaining better positioning in water. So these are the aspects of the fins. Now we're going to go into another picture. This is a close-up of the head of the shark. We can see other structures now, including the gills. We also have the eyes. The eyes are a great predatory feature in that it's large and able to detect many prey around its area. It also has openings here, and they function the same way the external gill slits do. And these openings are called the spiracles. They help to siphon water that travels into the gills, exchanging oxygen. And this is perfect in low-hanging scenarios whenever it's lying in sand or on the ocean floor, and it's not able to collect water through the external gill slits typically. So this is a great mechanism to have as a backup. But the gill slits do the same function as the spiracles. Now, at top the head, right here above the eyes, we have sensory pores known as ampullae, and they're really cool in that they detect electrical signals around the shark. And what I mean by that is when fish are moving, they send electrical impulses in their muscles that the shark is able to detect. And this is great for elusive prey for when they hide under sand or they disguise themselves, because although the shark may not be able to visibly smell or see them, but they can still detect them based on their movements. And that's what the ampullae are for. Another structure we could see here that's a sensory structure are the lateral lines of the shark. And these are pressure sensors, and they're able to sense changes in water pressure. So they're able to recognize waves as well as any other prey around its vicinity based on the pressure change of the water. Now we're going to move to the next picture, which is the underside of the fish. We have two nostrils here, the nose of the fish, and they have a great keen sense of smell that allows them to smell prey from large range away from them. And we notice that the mouth is on its underside, but within the mouth are, of course, it's another predatory feature are its jaws. They're very sharp. Of course, we've all seen the movie Jaws. We know that because of its sharp teeth, it's easy for it to grasp its prey, larger prey, in fact, and then chew them down to size so that they're able to ingest them. And here's another picture of an incision on towards the other end, we can see that the cloaca right here, this is pretty much the an opening, a genital opening for excrement as well as babies if this is a female shark. But this incision here is just for packaging purposes, as well as any injections into the circulatory system can be made through here. We can see some of the veins and arteries, as well as the central vertebrae. And that pretty much wraps up the first part of the shark. So we're going to move on to part two, the internal anatomy of the dogfish shark. All right, so this is the part two, internal anatomy of the dogfish shark. We can see here that an incision has been made into the coelom, which is a body cavity that houses most of the internal organs here. And the first structures that we see are large structures that are lobed in shape. For this in particular, this is a lateral lobe of the liver. In its entirety, the liver is comprised of 3 lobes, 2 lateral lobes off to its side, and then a middle lobe that's much smaller. We can only see the 1 lateral lobe. And their functions are that they help to store bile made by the gallbladder, which is right here. The gallbladder is in charge of making the bile, and the liver helps house the bile, but it also has detoxifying agents and aids in the providing oil that secretes throughout the entire body of the shark. Other structures we could see here are the stomach, and in the stomach you could see that there's kind of a difference in shape as well as color. This is the cardiac portion of the stomach, much muscular in shape, and this is the pyloric portion of the stomach right here, and it hooks in a J. And around here, where the pyloric end meets the small intestine right here, is known as the pyloric valve that acts as an entry point to the small intestine. And these, of course, the function of the stomach is to churn and house the food that has been ingested by the shark, and it gets pushed into the pyloric section here that ends up colliding with the small intestine. Above the small intestine here, we can see this grayish triangular structure known as the spleen, and the spleen is not in charge of digestion, it's more in charge of immune functions, so it supports the immune system. Some other key features that might not be as visible at the moment until maybe the next slide are, of course, the pancreas, and the pancreas is 2 lobes. One is the top over here that kind of meets at the point of where the stomach and the small intestine meet, and another one underneath the spleen, probably hidden underneath here, but they are in charge of digestion as well as glands. So we're going to move to the next picture. So we get a better picture, of course. So this is the pancreas right here atop in this area, and then another picture of the small intestine. And in the small intestine here, we could see the kind of like these walls here. This is the spiral valve, and the spiral valve is what's within the small intestine that helps expand and makes efficient use of its surface area, and it helps to slow the digested food in order for better absorption of the food before it gets excreted via the colon. Here we can see a strand. This is the bile duct, which is attached to the gallbladder, which makes the bile, of course, and that gets secreted into the small intestine here. Here's another shot of the lateral lobes of the liver, the middle liver, and another shot of the stomach. Now let's move on to the next picture here. I don't know if you can see this here. This might be a female shark, but this could be an ovary. This is part of the reproductive section, and it's usually underneath the digestive tract here. We can see parts of the esophagus that leads into the stomach, and inside the esophagus have this thing called papillae, which are like celiac projections that help to shuttle the food into the stomach, and in the stomach are flaps known as rugae, which are accordion-like flaps that help to expand the stomach so it can house larger food items so that it's easily held as well as able to churn over time so that it can pass through the stomach and into the intestine. And I believe those are it. And then we're going to move on to another picture, of course, more pictures of the digestive tract. Underneath the digestive tract as well, you can see kidneys, which are these projections that run along the wall, the body wall, and that can't really see this right here. And then we're going to get into the underside of that towards the tail end, which is actually the, sorry, my apologies. This is the rectal gland. Now, the rectal gland is exclusive in the sharks in that it helps to regulate the salt content within the shark's body. Since it lives in an aquatic environment, there's a lot of salty water, and this helps to reduce the salt content in the body so that the shark doesn't have to worry too much about the sodium levels of its health. Now we're going to move on to the other end of the shark. And in this portion, we see that there is the heart. And this is a two-chambered closed circulatory system, which is efficient in that it helps to deliver oxygen quicker to meet the energy demands, the high energy demands of a mobile creature like the shark. And beside the heart, of course, where the heart is housed in between are the gills. The internal portion of the gills here are much more easily seen. And then, of course, the liver makes another appearance, and so on and so forth. The reproductive organs are typically housed around here in this area. Once again, it might be a female shark, I'm not too sure. And I believe that is it for part 2 of the Shark Lab, and that completes the Shark Lab anatomy. And yeah, I hope you enjoyed. Thank you very much.